What were we learning about last time?
Square of opposition. Vowels.
Yeah, we were learning vowels. No, I don't think we were learning about vowels.
The square of opposition.
The square of opposition. Yes, that's what we learned last. What is the square of, what is at the corner of the square of opposition? All of them are
Vowels.
categorical propositions. All right. How many types of categorical propositions are there? 4. This is the quantity. What are the two categories of quantity?
Universal.
Universal and particular. This is what? Quality. And what are the two categories of quality?
Affirmative or negative?
Affirmative and negative. That's right. Affirmative and negative. All right. So this would be universal affirmative. How do you say that? All. Keep going. All S or P. What do S and P refer to?
Subject and predicate.
And subject and predicate are both what kind of thing? They're called terms. What does it refer to? What are terms? Categories, yeah, hence categorical propositions. Groups of things. Okay. Universal negative is?
No SRP.
No SRP. Now I want a chorus here. Particular affirmative is? That's pathetic. Some SRP. All right, a better chorus this time. Particular negative? Good. Some S are not P. Now, the vowel part was the abbreviations by which we refer to these. Universal affirmative is? Good. Now, turns out categorical propositions can be expressed in many non-standard ways. These are what is called the standard forms for categorical propositions. What is the one change I need to make if I say, all frogs are green? Why is that not quite in standard form? Green things, that's right. Even though it looks like this, we need, both of the terms have to be groups of things. And if one of them is just an adjective that's not good enough, you have to turn it into a group of things by adding the word things. All right. But it turns out there are plenty of non-standard ways of expressing categorical propositions. But if you're expressing a categorical proposition, it will be one of these 4, even if it doesn't look like it. So you have to be able to convert it from the non-standard into the standard. Suppose I were to say, there aren't any pink spiders. Which of the 4 types is that? There aren't any pink spiders. E. If it is E, then you will say no, and then the subject class. What?
Spiders.
Spiders. Now why is that a little weird? Because I said spiders second, didn't I? I said there aren't any pink spiders. But you just know that spiders is the subject. So no spiders are pink things. Good. So you are able to convert non-standard categorical propositions into standard form. Because you're natural logicians. Now, the square of opposition. Yes. Let's erase the square of opposition and draw out a new one. So the square of opposition is when we put each of the 4 types of categorical propositions at the corner of a square. Square of opposition. Turns out there are logical relationships amongst these. What is this one?
Contradictories.
Contradictories. What does that mean?
They must have opposite truth values.
Yes, so if you know the truth value of this one, you know that this one has to be the opposite. If this is true, this is false. If this is false, this is true. What is this one?
Contraries?
No.
Contradictory.
Also contradictories, yes. So there are two contradictions. What is this one? Somebody hasn't said anything yet.
Contrary.
Contrary. What does contrary mean? No, you're sorry. No, you're sorry you said it.
That they can't be both true.
Right, but they can be any other combination.
Yeah.
Yes, because this means they can't both be true, but it also means they can't both be false. Whereas contrary, they can both be false. So you just can't have true, true. You can have any other combination. So, if I know this is true, what do I know about this one?
False.
It must be false. Why? Because they can't both be true. Right, that's contrary. But, if I know this is false, what do I know about this one? Yes, in fact, I don't know anything about this one because it could be true or false. You can have, for example, this is possible, as in the example of cats and cute things. It's false that all cats are cute, but it's also false that no cats are cute. Whereas it could be this combination, it's false that all whales are reptiles. It's true that no whales are reptiles. So it depends on what we're talking about. So if you know that that's false, that doesn't tell you what this is. Okay? All right. What is this relationship? Subcontrary. And what does that mean?
They can't both be false.
They can't both be false. That's right. So if I know that this is false, what do I know about this one? It must be true, because they can't both be false. But if I know that this one is true, what do I know about this one? Yes, I don't know anything, because any other combination is possible. The only one that is ruled out is false, false. But you can have false, true, you can have true, true, you can have true, false. All right then, what is this relationship? There isn't one. Yeah, I tried to trick you, but you didn't fall for it.
Like that last time.
That's the relationship. It goes that way. What's that called?
Subalternate.
Subalternate. Which is the subalternate of which? Yes, think sub means under. So which one's underneath? O is. So O is the subalternate of E, but E is not the subalternate of O. I is the subalternate of A, but not vice versa. All right. What is subalternate? What does it mean? Means if the universal one is true, then the other one has to be true. Yes, now let me say a little bit about this. So what this means is if we know all whales are mammals, we know it's true that some whales are mammals. And on the face of it, that sounds right, but we might think, well, that's a little odd. You don't say, I don't know, some men are humans. Well, you might, but that would be a diss on that some men you know. You would say some and some are animals. Well, humans are animals, but because in the way we normally speak, if you say some something or something else, it sort of carries the implication that some aren't. But in logic, it doesn't. So think of it this way. I hand you a bag of marbles. It's clearly full of marbles. You reach in, you take out a red marble. Okay? Do you know it's true that some of the marbles in the bag are red? And remember, some means at least one.
Yes.
Yes, you do. Do you know that some are not?
No.
No, you don't. So all that some SRP means is there is at least one S that is P. It doesn't mean that there are any that are not. It doesn't carry that implication. It just knows that it means that there is at least one that is. Okay? So if we know all whales are mammals, do we know that there's at least one whale that's a mammal? Of course we do. So that's why subalternate works. All right. So if I know this is true, I know
True.
this is true. What if I know this is false? What's that? Well, let's think about it. What is the truth value of all whales are reptiles? False. What is the truth value of some whales are reptiles? False. So that combination is possible. But does it happen every time? Well, what is the truth value of all cats are cute? False. What is the truth value of some cats are cute? True. Uh-oh. So it is possible to have that combination. So if we know this is false, what do we know about this one? What have I just done?
It could be true or false.
It could be true or false. So in other words, we don't know. So this being false doesn't tell us anything about this one.
So the only thing we really know is that if it's true, the other one.
Well, that actually tells, so we know that if this is true, this has to be true, right? Suppose we know that this is false.
Then that would make it false.
Then this would have to be false. Why? Because we know that if this is true, this has to be true. So if this isn't true, then that one can't be true. Because if it was true, this would be true. But it isn't. So this one can't be true. Right? Logic. Right? Yeah, if this is true, this has to be true. So if this isn't true, well, this can't have been true.
So it only depends on A.
Well, no, because if you know what this one is, if you know this one is false, it tells you that this one is false. If you know this one is true, you know this one is true. But the other two don't tell you anything. So suppose I know this one is true. It doesn't tell you what this one is. Remember, so if I've handed you a bag of marbles, you've taken out a red one. Do you know that some marbles in the bag are red? Yes, so you know that this is true. Do you know that all marbles in the bag are red? No, you don't. All right, let's put these logical relationships into action. Let's say S in this case, so, oh, by the way, all of this assumes that S and P is the same for all four of them. I mean, obviously, knowing the truth value of all whales and mammals doesn't tell you the truth value, anything about the truth value of some cats are cute, right? It has to be that they're talking about the same terms. All whales are mammals, some whales are not mammals. All right, let's say, imagine that S is blurps. So, all blurps are flinky things. Turns out that's true. On a piece of paper now, work out the truth value of the other three. Work out the truth value of no blurps are flinky, some blurps are flinky, and some blurps are not flinky. This is my example of logic being useful. Not a very good example to prove that. But it is, we can now work out the truth value of completely different categorical propositions on the basis of knowing the truth value of one categorical proposition. That's called logical deduction. All right, everybody, what is the truth value of E?
False.
How do you know?
Contrary to each other.
Because of the relationship contrary. You know the truth value of the contrary of this one. And you know, furthermore, you know that it's true. So why does that tell you that this one has to be false? Because they can't both be true. That's what contrary is. Okay, good. Everybody, what is the truth value of O?
False.
False. Everybody, you agree? How do you know that?
Because A and O are contradictories.
Because A and O are contradictories. That's right. So whatever. Now, suppose you just knew that this was false. Well, actually, we'll come to that. What about I? Everybody? True. Now, there are 3 ways you could know that. What is one way? And so you know by what relationship? Subalternate. So you know that the universal is true, so by its subalternate will be true. What is another way you could have known that I was true?
E is false.
By what is false? E is false? Okay, so you know that this is by what relationship? Contradictory. So in other words, you know that the contradictory of I is false, so I must be the opposite of that. Yes. What is the third and final way you could have worked out the truth value of I? Subcontrary. You know that the subcontrary of I is false, and you know that they can't both be false, so this has to be true. Yeah? Oh, I'm sorry. Just getting word. Apparently, we were wrong. This is false. Well, you know, we're working on the cutting edge of biological science here, so. Now work them out. If it is false that all blurps are flinky things, what would be the truth value of the other 3? All right. We know that A is false. What do we know about O, everyone?
True.
Why do we know that? Because they're contradictory. It has to be the opposite. All right. Who can tell me the truth value of E? Raise your hand if you think you know the truth value of E. Yes,
It's
Karen.
false.
You say that it is false. How do you know?
Because if O is false, no.
But O is not false.
No, we don't know that yet.
Well, we know that it isn't.
Yeah, we do know it is. It's true. I know that because if, because A and E are contraries. And
Now, what is it to be contrary?
they can't both be true, but they can both be false. And so,
But they can both be false, but they could also be false and true.
okay. I suppose I don't know.
Okay. Anybody think they do now? Is it you say that it's true? Why do you say that it's true?
Just
Because it wasn't false?
yeah, but that's what I thought at first. Just because that would be like A,
Yeah.
I has to be true, and then it would be
I has to be true. Wait a minute. Why does I have to be true?
That's what I think.
In fact, what is the right answer? We don't know. We don't know. Why? Well, this one doesn't tell you, because they can both be false, like all cats are cute is false, no cats are cute is false. Or, but maybe blurps and flinky things are like whales and reptiles. All whales are reptiles is false, but no whales or reptiles is true. So you don't know if blurps and flinky things are like cats and cute, in which case they're both false, or are like whales and reptiles, in which case this one would be true. You don't know. Could be either. Both opportunities are left open. You only write in a truth value when you know it can only be that. You don't say, it might be that. It's not good enough. So you know for sure that this one is true, because contradiction never lets you down. What about I? Also don't know. Of course, if you did know I, you could work out E. but sadly you don't know I. Why not? Why can't you work it out with sub-contrary?
Because they just both can't be false.
Yes, all you know with sub-contrary is they both can't be false, but true, false, and true, true are both equally possible, and you don't know which it is. So in fact, you can only work that one out. Logic. Funny stuff. I didn't say it was fun. I said it was funny. But not funny, to quote Ralph Wiggum. All right. Yeah, there are some examples in the book. So for example, what is the relationship between these two? All S are P, some S are not P. What is the relationship between those two?
Contradictory.
Contradictory. So if the first one is true, the second one is
False.
false. All right. No S are P, some S are not P. What's that? Which is the subalternate of which? Some S are not P is the subalternate of all S are P, but of no S are P. But no S are P is nothing to some S are not P. There's no name for that relationship. But if I know that no S are P is true, what is the truth value of some S are not P?
True.
Is he right?
Yep.
Yes, he is, because we know that if the universal is true, the particular is true. All right, suppose I know that some S are not P is false. Do I know the truth value of no S are P?
No.
Who said yes? And what, so if some S are not P is false, what is the truth value of no S are P? Yes. Remember? If the particular is false, you know that the universal is false. I mean, if you know that some cats are reptiles is false. I'm sorry, if you know that some cats are not mammals is false. You know that no cats are mammals has to be false. You do. You may not know you know that, but you do. All right, let's move on. I mean, there are questions like that on the homework. If you're struggling with them, Eric is your man. Or you can email me and ask me about them. But there's going to be questions like that where it's asking you to work out the truth value of one out of the truth value of other. And it will either be false, true, or question mark. If you know this is false, you don't know what this is. If you know this is true, you know that this one is false. Yeah? All right. Now, let's move on to the new material. There are, in the book, they call this immediate inference. I'm going to call it functions. Why? Just to be different. Okay. A function sounds more complicated than it is. Sounds scary and mathematical. Well, it is mathematical, but it's not scary because you know a lot of mathematical functions. For example, you know arithmetic. I'm sorry, you know addition. Addition is a mathematical function that we are all very familiar with. What a function is simply something that takes in an input or inputs and produces an output. So, suppose I have a big box that does addition, and I throw in a 3 and a 2. It makes a rumbling and groaning noise, and what pops out the bottom? 5, because that's what addition does. If it has 3 and 2 as inputs, it produces 5 as an output. Now, it's a numerical function. Why? Because the inputs and outputs are all numbers. Okay, so you're familiar with functions. we're about to learn about not numerical functions, but functions to do with categorical propositions. Specifically, these three: converse, obverse, and contrapositive. These are three functions for categorical proposition. And just like all functions, they take an input. In this case, they're not like addition. Addition takes two inputs and produces one output. They're more like square root. What is the square root of 16? 4. Yeah, that's something that has one input and one output. Same with all these three. You take a categorical proposition and you can perform any one of these functions on it, and it produces a new categorical proposition. Okay? Simple concept. Now you just need to know how each of them work. So let's look at converse to begin with. Converse is simple. All that converse does is it switches the terms. So if our input is all SRP, what will its converse be? Exactly. It's that simple. Now this is a little bit confusing because what does S stand for? Subject. But what is the subject of all PRS? P. So you have something called the subject, which is now the predicate, but that's what converse does. Okay? So what is the converse of all whales are mammals? All mammals are whales. And actually, now that we've got to converse, I can explain why I was so picky about adding the word things. You know, so I wouldn't let you say all, I don't know, all waterfalls are beautiful. You had to say all waterfalls are beautiful things. Why? Well, if I don't do that, what is the converse of all frogs are green?
All green are frogs.
All green are frogs, right? Does that make sense? No. What does make sense is all green things are frogs. Okay. So that's converse. What is the, we've already done all SRP, destiny. What is the converse of no SRP? Don't overthink this. You just switch the terms. You don't change anything else. Well, what did he say? Yes, that's right. What is the converse, let's see, Philip, what is the converse of some SRP?
Some PRS.
Pretty easy. Hunter, what is the converse of some S or not P?
Some SRP.
No.
Hold on.
The converse of some SRP is, not P is, just switch the terms,
Oh, okay. Some PRS.
not S.
Yeah, not that.
Yes. So in other words, let's see. This. Okay? Easy peasy. Converse is fairly straightforward. Now, this last column asks whether or not it's legitimate. The function is legitimate. Now, what it is for a function to be legitimate, I'm going to say, and you're going to write down, but I'm not going to bother to write down because I'm lazy. A function is legitimate if it preserves the truth value of the original, of the input. So converse is legitimate if you start with a true categorical proposition and the product is true, the converse is true, in all possible circumstances. Okay? Let's see if we can work this out. All whales are mammals. What is the converse of that one again?
All mammals are whales.
All mammals are whales. What is the truth value of all whales are mammals? True. What is the truth value of all mammals are whales? False. Why? Because there's plenty of mammals that are not whales, like us, for example. Unless some of you are whales cunningly disguised. So that tells us that Converse is not legitimate for A types. No, not legit. That makes sense? Because it doesn't preserve the truth value. It doesn't say the same thing. Essentially, another way of putting it is legitimate is a function is legitimate for a type if the result of the function says the same thing as the original. That, in logic, that's the same as being truth preserving. If it doesn't affect the truth conditions, then it says the same thing. If the truth conditions are the same in the original and the result, then they're saying the same thing and the function is legitimate. All right, but we're going to hold off on looking at legitimacy until we explain the other functions. Obverse is the next one. No longer a type of shoe. Obverse is more complicated than Converse because there are two steps to it. The first step is to switch the quality. So, if my original is all SRP, what will be the first word of its obverse? Who said that? Destiny? Yes, you're right. It's no. Why? Why? Because changing the quality means if you start with affirmative, it becomes negative. Now, you don't change the quantity. You never go from all to some. You just go from all to no, or if you start with no, you go to some. Or if you go from some are, you go to some are not. If you start with some are not, you go to some are. Okay? But that's just the first stage. The second stage is you replace P, the predicate, with its complement. Okay, well I better explain what a complement is. And I don't mean you look nice today, even though you do all look nice today. That's a complement with an I. This is a complement, like complement. What is a complement? Anyone come across this in math? No? All right, well, we're ahead of your math. The complement of a set or group, it doesn't matter, group or category, is the set or group or category of everything that is not in the original. Now, what this means is that a set and its complement are both mutually exclusive and jointly exhaustive. Do you remember those terms? It was just a week or so ago we were talking about that. What does it mean for two groups of things to be mutually exclusive? I don't think that's quite right. If two groups are mutually exclusive, what does that mean?
Only one can exist. Like only
The
one.
other must die. It's like Harry Potter and Voldemort. No, it means, if they're mutually exclusive, it means that they share no members in common. So like cat and dog are mutually exclusive. I know there's that cartoon character Cat Dog, which you're probably too young to remember, but it's not in either. So cat and dog are mutually exclusive because if you're a cat, you're not a dog. All right. What does jointly exhaustive mean?
Means that put together it covers all possibilities.
That's right. So remember, the example we used to illustrate these concepts was classifying movies. So if I came up with two categories that were jointly exhaustive, then whatever film I came up with, it would be in at least one of them. So if two sets are mutually exclusive and jointly exhaustive, that means that anything is in only one of them. Anything is in one of them is jointly exhaustive, and only one of them because they're mutually exclusive. You can't be in both. Make sense? All right, so a set and its complement are both mutually exclusive. If you're in one, you're not in the other, and they're jointly exhaustive. If you have to be in one of them. You cannot be in neither. All right, with that in mind, let me ask you this question. Is the complement of ugly things beautiful things? Yes or no? Are ugly things and beautiful things complementary?
No.
No. Why not?
There's like okay things.
Yes. In other words, they fail one of the categories. They are mutually exclusive, because if you're ugly, you're not beautiful. I know, you know, beautiful to some, ugly to other people, as you can tell from babies. But there's a Seinfeld episode about that. There's a Seinfeld episode about everything. But, yeah, I mean, this piece of chalk, is it beautiful? No. Is it ugly? No. Well, this piece of chalk proves, therefore, that beautiful and ugly things are not jointly exhaustive, because there are things that are in neither. Most things, I would say, are in neither. Okay, so what is the complement of ugly things?
Not ugly things.
Yeah, or we're going to say non-ugly things. So the way to turn a set into its complement is very easy. You just write non-hyphen in front of it. So the complement of P is non-P. Very good. All right then. With that in mind, what is the obverse? Jet's not here. I was going to pick on him. Josh, you get picked on instead. What is the what is the obverse of all SRP? First, for the first word, remember this rule.
No S.
No, good. S. S is unchanged, so you can get no S. And then you have to think about this rule.
Are non-P.
Yes. So the obverse of all SRP is no S are non-P. Ethan, what is the obverse of no SRP?
No, that's
No.
Oh, no, I was just saying it over.
Oh,
I'm
okay.
trying to give you the exact same thing.
All right. So you said. All right. Yes. What is no SRP? What is its
Some S are
obverse?
non-P.
What's that?
Some S are non-P.
You changed
All
the
right.
quantity.
All S. No, I can't talk right now, obviously.
So we started with no SRP. So the first word is going to be
No. All.
oh. All. Yes, because we're changing the quality. We never change the quantity. So if it's
Okay.
universal, it stays universal.
Okay.
All right. But if it's no, it becomes all. All right. So all S. Now you remember this
Or
word.
non.
Yes. So the obverse of no SRP is all S are non-P.
Okay.
Zainab, what is the obverse of some SRP? Good so far. Some S. Yes, yes. Keep going. Yes. Yes, some S are not, because we started with some S are, so you've got to change the quality at some S are not, and then you replace P with its complement, non-P. So it becomes some S are not, non-P. All right. Brandy, what is the obverse of some S are not P?
Some S,
Good start. Like it so far?
R, P,
Yes?
R, P, R, non-P.
Well, which?
Some S, R, non-P.
Yes, that is correct. So it becomes an I type. You started with an O type, so it becomes an I type, so it's some S R, but then you replace P with non-P, so it becomes some S R non-P. Okay? So far so good? Make sense? Let's move on to contrapositive then. The rule with contrapositive is well, just like obverse, there are two things that you have to do. And of the two things, one of them is actually conversion. So, to produce a contrapositive, the first thing you do is to do converse. Okay. Then you replace both terms with their complements. Not just P this time, both of them. All right. So, Samantha, what is the contrapositive of all SRP? Remember, conversion is just flipping the terms. So A is flip the terms, B is replace both terms with their complements. So you start with all SRP, you end up with, that's just conversion. I need the second step too.
I missed that when I was writing the ones.
So you've done Converse, which is step A, but do step 2 now. B.
So, no.
No, you don't have to change the quality. Yeah, in fact, let me state this. Of these 3, in only one case do you change the type of categorical proposition that you end up with. Which one of these 3 is it? Obverse. The other ones, because you change the quality. So if you start with an A type, you end up with... If you start with an A type, its obverse is a what type? An E type. If you start with an O type, its obverse is what type? I type. Whereas converse and contrapositive, if you start with an A type, you end up with an A type. Okay? So this is the only one that changes the type. And you never get one that changes the quantity. You never go from an A to an I or an O. Alright, so if the original is all SRP, the first word of the contrapositive will also be all. So we got as far as all.
So, all P are...
Now, see, you're still just doing conversion. All.
Oh, so you leave the non in front of the first, in front of P every time.
Well, the converse, if you replace S, you replace it with its converse. What's the converse of S? Non-S. So all SRP becomes all non-P are non-S. Everybody's managing one of the stages, but not both. Yes, because look, you start with all SRP. Stage 1 is you switch the terms. So you get all P are S. Stage 2 is you replace each of the terms with their complement. So you stick none in front of both of them. And you get that. Yeah? All right then. What is the contrapositive of, wait, didn't crowd today. Cat. What is the contrapositive of no SRP?
No non-P are non-S.
Absolutely right. Good. Charbel, what is the contrapositive of some SRP?
Some SRP,
Yeah, okay.
some non-S.
Now,
Some non-P are non-S.
yes. Jordan, what is the contrapositive of some S are not P?
Say it again. I was writing it down, sorry.
What is the contrapositive of some S are not P?
Some P.
No.
Some non-P are non-S.
You missed out a word. What was the word you missed out?
Not.
Some not
Some non-P.
are not non-S.
Yes. Okay, so it looks like this. Now the question we ask is, are they legitimate? We've already seen that the converse for A types was not legitimate. Why not? Because whales. Yeah, because the original was all whales are mammals, which is true. The converse would be all mammals are, which is not true. So for it to be legitimate, if the first one is true, the second one is automatically true. They mean the same, but they don't mean the same. They're not conveying the same information. How about no cats are dogs? What is the converse of no cats or dogs? We're doing converse now. No dogs or cats. It is true that no cats or dogs. What is the truth value of no dogs or cats? Also true. So what do you think? Legit or not? Yes, it's legit. It's too legit to quit. You people are too young to remember that. You probably go. All right, what about some cats are cute things? What is the converse of that? Some cats are cute. The converse is? Some cute things are cats. So converse is what for I types? Legit or not legit? Legit. Yes. All right, now what about the last one? Some cats are not cute. Some cute things are not cats. Sounds legit, doesn't it? But let's be careful. If I think of another example, it won't sound so legitimate. Is this true? Some humans are not men. Yes, all you women should be nodding your heads, right? Some humans are not men. It's certainly true. What is the converse of that? Some men are not humans. Now you might think that, but in fact that is false. So that tells us converse is not legitimate for O types. Okay? Now, all whales are mammals. What is the obverse? No whales are non-mammals. Is that legitimate? Yes. Are you sure? They do have the same truth value. All whales are mammals. Every single whale is a mammal. That tells us what? No whales are non-mammals. So in fact, obversion is always legitimate. It is just another way of saying the same thing. Okay. Now, contrapositive. A little trickier to work out. What is the contrapositive of all whales are mammals? No?
All non-mammals.
Yes, all non-mammals are non-whales. What do you think? A little harder to work out. Well, fear not, because what we're going to learn next is going to make it easy to work out. And what we're going to learn next is awesome. Well, of course it's awesome. We're doing logic. Venn diagrams. You have probably heard of Venn diagrams. Has anyone not heard of Venn diagrams? Okay, good. I'm not sure, though, that what gets called Venn diagrams in other circles counts. I mean, I dimly remember learning about what we called Venn diagrams in math when I was a kid, many centuries ago, and we had things that looked like this that we called Venn diagrams. No, that wouldn't count as a Venn diagram for logic. In logic, ignore this cross for now, I'm just setting something up. All Venn diagrams look like this. Is that what you've always called Venn diagrams? Yeah. Two overlapping circles. That is what a Venn diagram does. Okay, now we're going to use Venn diagrams to represent categorical propositions. So if you are diagramming a categorical proposition, any categorical proposition, you start like this. So what do you think the circles represent? Subject and predicate, that's right. What are there two of in every categorical proposition? The terms. Now, whatever categorical proposition you are representing, even if it's all non-P or non-S, this circle always represents S, this circle always represents P. Now the reason why I drew this grid is we're going to draw a Venn diagram to represent each of the four types of categorical proposition. A, E, I, and O. But always this is S and this is P. Okay. Tips for Venn diagrams. First, if the categorical proposition is particular, put an X. If the categorical proposition is universal, I'm not going to tell you yet. Some of you will have read ahead, but no spoilers. Okay, so we're just going to focus on I and O. To represent some SRP, I am going to add an X to this diagram. There are 4 possible places I could put it. You can never, when you are diagramming a categorical proposition alone, put an X on a line. It has to be entirely within a region. And it turns out that a Venn diagram represents the entire universe and divides it up into 4 regions. 1, this little moon shape on the left. 2, the cat's eye, as I call it. 3, the moon on the right. And 4, everything else. Goes off to infinity. Where shall I put my X? Now, X represents something. X means there's something here. That's what X means. X marks the spot where there is a thing, at least one thing. Where does my X go if it is true that some SRP? What region? We have a vote for 2. Who agrees? Why?
Because it's both S and P.
Yes, because when you're saying some SRP, suppose I say some whales are mammals. Then I'm saying there's something in the overlap between whales and mammals. There it is. Now some SRP means there is at least one. So we'll just focus on that one and put an X on it. But there could be many. Okay? So this is the diagram, and I'm going to take the numbers away because they're not actually part of the diagram. They're just part of my system. This is my system, this number system, and it's not in the book, and it's awesome. So you better take notes. I have got a handout that covers this. Wow. All right. Some S are not P. Where shall I put my X? Be polite now. Well, there's 2 possibilities of the S circle. Yes, in fact, that's tip number 2. So, tips for Venn diagrams. If the categorical is particular, put an X, dot, 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 in the subject term. So, whenever you're drawing a Venn diagram, whatever you're doing, putting an X or whatever we do for universals, which I'll get to in a second, you're putting it somewhere in the subject term. Now the subject term is always going to be how many regions? 2, because S is 1 and 2. So you know actually, because S is the subject of all of these, is S always the subject of every categorical proposition? No. No, even though it says sub S. Why? Because we've just seen examples where it isn't, like all non-P are non-S. What is the subject term of all non-P or non-S? Non-P. Okay, in that case, you would be putting your X, well, no, because it's all. If it was some non-P or non-S, you would be putting it somewhere in non-P. Now, you don't know where non-P is yet, but we'll get to that in a second. All right. So I know it has to be in region 1 or 2. I also know it can't be 2. That kind of narrows it down. Where do I put my X? In 1. Why?
It's not S and P, it's just X.
I know it's S, because we're talking, there is at least one thing that is S. It's S, but it's not P. So it has to be inside S and outside P. So it's region 1. What's that?
What was the sentence?
some S are not P. Yeah, it's an O type. Some S are not P. Okay? Now we're going to do universal. Slightly more difficult. You shade. You don't throw shade, which is a phrase I've just learned, because I'm old. You shade. And you shade the entire region, but only one region. So you'll be shading, if you're shading 1, you'll be shading this entire moon shape. If you're shading 2, you'll be shading the cat's eye. If you're shading 3, it'll be this moon shape. And if you're shading 4, you have to go into infinity, so I hope you've got a big pencil. All right. Here's the important and slightly counterintuitive fact. X means something. Shading means nothing. Well, it means something, but it means there's nothing there. So, when you're shading a region that you know is entirely empty on the basis of the categorical proposition. Let's do the easier one. If no S is P, which of the 4 regions do you know is empty?
2.
Who said 2? Why? Why do you know 2 is empty? What's that? Yeah, so if you say no cats or dogs, in fact you mean there's no overlap between the 2 groups. Well, here you always have an overlap, but so that we indicate that that overlap is empty. If this is cats and this is dogs, what would be in region 2? A cat dog. But if no cats or dogs, there aren't any, so this region is empty. Okay? Well now, you can also work out by a process of elimination where I have to shade for an A type. How do you know it's region 1? Because it has to be in the subject, it has to be 1 or 2, and it can't be 2. Alright, but what's the real reason that all S are P, I shade region 1? How do you know that region 1 is empty if all S are P? All whales are mammals. What would be in region 1?
Whales that are not mammals.
Whales that are not mammals. But if all whales are mammals, how many whales are there that are not mammals? None. In fact, what is the obverse of all whales are mammals? The obverse. Remember, obverse is always equivalent. No?
No.
All mammals.
No whales are non-mammals. All whales are mammals is equivalent to no whales are non-mammals. So this no whales are non-mammals obviously has the same diagram because they're equivalent. There's nothing that is both a whale and not a mammal. So this region is empty. Is that making sense so far? All right. Okay, we're going to go 1 minute over time. At least. You didn't hear that last one. All right. We've learned how to diagram the basic kinds, the basic 4. But notice we also have freaky ones like, let's do some non-P are non-S. Oh, before I go on, what is the relationship according to the square of opposition between these two? They are contradictories, which means that this one says the opposite of this one. Why is that obvious from the diagram?
Because there's things in the eye.
Because this one says there is something in region 2, whereas this one says there's nothing in region 2. These two are contradictories. This one says there's something in region 1. This one says there's nothing in region 1. Clearly they're saying the opposite thing. Okay. Now, if 2 categorical propositions are equivalent, they will have the same Venn diagram. This is the contrapositive of this one. So if they have the same diagram, it means that contrapositive is legitimate for I types. Does that make sense? Because it means that when you do the contrapositive, you're saying the same thing. Well, let's see. How do we do this? Well, here's my method. So pay attention. It's a great method. There are 4 possible terms. S, P, what are the other 2? Non-S and non-P. Each of them consists of two regions. S consists of what two regions? 1 and 2. P consists of what two regions? No. 2 and 3. Well, but if S is 1 and 2, what is non-S? 3 and 4, because non-S is everything that isn't S. And if P is 2 and 3, what is non-P? 1 and 4. Okay. Now, we know from the second rule, I'm going to be putting an X in one of two regions. I'm going to be putting it somewhere in, I'm going to be putting an XY, because it's sum. I'm not going to be shading because it's particular. And I'm going to be putting an X somewhere in non-P, which means what two regions are possible?
1 and 4.
1 and 4. Now, if I'm saying some non-P and non-S, I'm saying there's something in the overlap between the two. Right? Because when I did some S, R, P, I put it in the overlap between S and P.
So 4.
So, 4, why?
Because they overlap with 4.
Because I'm going to be putting it in the overlap between non-S and non-P, which is region 4, which is out here. So, is contrapositive legitimate for I-types? No. And we just illustrated that. We worked that out using a Venn diagram, which is good, because it might have been hard to work out just intuitively. We'll take this up next time.